Hello, and welcome to Breast Cancer Conversations, a podcast brought to you by survivingbreastcancer.org. I'm Laura Carfang, breast cancer survivor and founder of survivingbreastcancer.org, a nonprofit organization providing community, education, and resources to empower those diagnosed with breast cancer and their caregivers from day one and beyond. Welcome to another episode of Breast Cancer Conversations. My guest today is Jim Foote, and he is going to enlighten me and you on this really amazing topic of how we can really help advance cancer in terms of leveraging AI technology and really go beyond just like genetic testing. Because a lot of us, when I hear the word precision medicine or functional medicine or all of these things that are going to be tailored to me as the patient, I think this is fantastic. I'm one of those people who want to have as much information as possible so I can be informed in making my decisions about my own treatment. And with AI now really just like shaking the world, I don't even want to say by surprise, just like disrupting in all of the best ways. How are we leveraging technology to really advance cancer therapeutics? Welcome to the conversation.
I'm Jim Foote. I'm one of the co-founders and CEO of First Ascent Biomedical. We have two labs actually in Miami, Florida. One is a research lab and the second is a commercial lab that we can provide functional precision medicine and personalized cancer treatment plans to patients who have failed the standard of care.
Interesting. Okay, so let's just unpack that a little bit. So functional personalized medicine, what does that actually mean?
Yeah, it isn't anything new. Functional precision medicine the concept has been around for decades. The ability to do it affordably and using technology as an enabler are really things that have just transformed in the recent future. What it is, genetically, we acknowledge we're different, right? Our biology is different. Our DNA is different. But when we get cancer, we're all treated based on the standard of care. It's a recipe book. And if you and I got the same cancer, we would get the same recipe. Now, it would vary a little bit based on our weight, our age, and our weight. But it's, for the most part, the same treatment plan. What functional precision medicine is it actually builds on your individuality and designs a treatment specifically for you and how your cancer cells respond to these different drugs. So it gives us that individualization versus the standard of care, which is based off of averages.
Fascinating. So I'm just trying to put this in like my context, right? So if I was diagnosed with breast cancer and I go in, there's, depending on my stage, my type and my subtype and all these things, there's that standard of treatment plans that we all follow, right?
That's correct.
There is a way now to take through a blood sample or through my DNA to be able to understand my biology?
Yeah. So what we do at First Ascent is it starts with a biopsy and we have to have fresh tissue. But we've developed a process in which we can rapidly enrich your cancer cells, not just the tumor bulk, but the chemo-resistant cells, to the point that depending on the biopsy size, we can test hundreds of FDA-approved drugs against both cell populations to figure out what works. We combine that with genomics, and our AI analyzes all of that data, and we provide that data back to you and your doctor in an average of 10 days. And it's a personalized plan that's as unique as your fingerprint. It shows the doctor exactly which drugs are effective against your tumor and which ones aren't. And it allows the doctor and the patient to make better choices about which drugs to use. And just as important, to eliminate drugs that oftentimes will be 100% ineffective and very toxic.
So I love that. So that's going to be my next question too. So you're able to test the myriad of chemotherapies, immunotherapies, all these drugs against my particular tumor biopsy to understand how it's responding?
Correct.
That's amazing.
And so it's, again, the whole idea is you're unique. You're an individual. And so why not have your cancer treatment be as unique as the biology of your cancer? And that's where we're really excited. What we were able to publish prospectively in Nature Medicine is on refractory cancer patients, is when doctors allow our platform to help guide treatment, patients benefit 83% of the time better than the standard of care or doctor's choice. Now, these are cancer patients that have already failed the first line of treatment. And we know statistically that if their cancer has come back and they failed that first line of treatment, there are very few options left. And that's where, the power of personalization really comes in, is instead of guessing at what we think is going to work next, we test and we treat.
Yes.
So it takes us from, trial and error to testing and treating. And that's where, working with doctors and patients, that's where we've been able to, achieve the patient benefit like we were able to publish.
That's incredible. And so are you working mainly with metastatic patients?
Yeah, it's not metastatic patients, but, again, the standard of care exists, and it's benefited, again, it enables 2/3 of the cancer patients to survive. Our focus is those 1/3 of the cancer patients that their cancer returns and there are a few options left.
I see.
And mostly, I believe probably your next question is going to be, well, why can't I be used upon primary diagnosis? Ideally, that's where we would like to be, is to be able to personalize that treatment plan as soon as you're diagnosed, not after you've metastasized or failed the standard of care. But we've got to continue to build a lot more data that will support changing that standard of care. So for now, our focus patient are those who have at least failed one line of treatment, because under the right to try, if you failed that first line of treatment and you have a life-threatening disease, you as a patient have the right to try whatever means that you need to save your own life. And it transfers a lot of that responsibility from the doctor to the patient to have more control over what that looks like.
Yeah. And it's not uncommon that we hear, because cancer is so complex and sneaky, it can lay dormant for a number of years. You can be in remission or no evidence of disease or no evidence of advanced disease. And so when cancer comes back or metastasizes even to distant parts of the body, it may have a completely different genetic makeup than it did at your initial diagnosis. So are you then rebiopsying when the cancer comes back?
Yes. So we have to, because again, part of what these chemotherapy drugs do is they change your DNA. And so if you're undergoing treatment and your cancer comes back, we need a fresh biopsy, because fundamentally your genetics have changed and your response has changed. And obviously you've developed a resistance to certain chemotherapies. And so, what we can do is, from a fresh biopsy, we analyze what drugs work, we analyze which drugs don't, based on the individual, not averages, and we return those results back to you and your doctor in about 10 days.
What has been the most surprising to you?
A couple of things that really stand out is, I'll share with you a couple of cases. We have a patient that we've helped where we got a biopsy from the primary site and a biopsy from the metastatic site. And the drugs that worked on the primary site didn't work on the metastatic site, and vice versa. And so when you think about a doctor that doesn't have access to a tool or technology like this, they're really trying to grasp at straws, but they'll never be able to see, drugs that worked on one site didn't work on the other until after they've treated several rounds of therapy. What we can do is, again, we can find the synergy. So we can find the drugs that are effective on both sites and provide that list back to the doctors so they can select which treatment is most appropriate for that individual patient.
So you're really tailoring that treatment plan for the patient and the doctor to have those conversations that might otherwise not have been presented, because it's not kind of following the standard of care and kind of that step process of here's your next line, and then we progress to third, fourth, fifth clinical trials.
Yeah, no, that's it. Yeah, that's it exactly. And I think that's the beauty of what we do. And even, when we talk a little bit about our AI, you talk about large language models in AI. What are they trained off of? They're trained off of a whole bunch of people that hopefully look like you and I. So fundamentally, AI is going to help advance the cancer treatment protocols statistically. But it really lacks that individualization, because, again, if we take a step back and we say, and we acknowledge, genetically, you and I are different. our biology is different and our cancer biology is different. So those large language models that we use to train AI are based on a whole bunch of people that hopefully look like you and I. What our AI is trained on is all of the data that we use to train our AI is about you. It's how do your cancer cells respond to these different drugs? What do your genomics look like? DNA and RNA. All of that data coming together, our AI analyzing it and making that recommendation back to the doctor. So the entire data set that we use to train our AI model is based on the individual patient.
That's a lot to wrap my head around, to be honest. And when we think about building this like knowledge base, this data set, using all of my information to find out what treatments are going to be best for me, my head immediately goes to, what if it comes back with, chemo A and B that have never been paired together before? Are there risks or concerns that the oncologist needs to kind of weigh, because we're kind of venturing into new territory potentially?
Yeah, so when we return results back to the patient and doctor, we basically provide all of the literary sources where that drug has been, or that drug combination has been used on a particular cancer type, or where there has been a study or some published literary evidence. But in some cases, yes, it will be a combination that has never been used on a patient before, or there's no literary sources referencing it.
So they're FDA-approved drugs, but they just haven't necessarily been utilized in this context.
Right. But they are all FDA-approved drugs. And these are all drugs that the physicians are familiar with. It's called off-label use. Okay. So, again, if we use breast cancer as an example, breast cancer has a biomarker called HER2 positive. And there was a drug developed called trastuzumab. And trastuzumab is very effective against knocking out HER2 positive breast cancer. They use it about 82,000 times a year to help men and women with breast cancer. The 500 patients that have HER2 positive bladder cancer, the doctor would never think about giving you trastuzumab because it's only been approved for breast cancer. But when we show them the evidence that trastuzumab is very effective against this patient's HER2 positive bladder cancer, they know the drug, they know the dosage, they're familiar with it, and it helps connect, that drug with that particular cancer type. Does that help?
Great example. Thank you for that. And let me think about that for a second. So are you almost doing like a matchmaking between like the genomics of like the person and the database of drugs out there?
Yeah, I'm
simplifying. I'm definitely oversimplifying AI here.
No. Here's the easiest way, because again, most everybody understands genomics, right? DNA, RNA. Think of your genomics like a blueprint. It's like, a blueprint of a car. And it tells what exists, that's the DNA, and then what's active, that's the RNA. And again, it's just a blueprint. But what functional drug testing does is it's like taking that car out on the track and seeing how it performs in the turn at 90 miles an hour. So it actually tells you how things are going to perform and takes you away from just reading the blueprint and hoping that it works.
Excellent.
Does that help?
It does. Absolutely.
Okay.
And so how far along are you like in this process? Because I know our listeners are going to be like, oh my God, this is fantastic. You've like figured out the answers to all of my problems right now. Like, What next? And I would love to also piggyback on that. Like, how did you even get into this field?
Yeah. So where we are today is we have completed 3 clinical trials. We have 2 clinical trials running right now. And I hate to use the word clinical trial because it almost sounds like we're trying to see if it works or it doesn't work. Our clinical trials are actually guiding treatment. It's not experimenting to see if it works or we hope it works. It is guiding treatment. And we have 3 more trials in the pipeline that are about ready to get kicked off. We have a CLIA lab that just opened at the beginning of September. And what the CLIA lab allows us to do is to begin helping patients outside of a clinical trial, to basically deliver exactly what we've talked about. We haven't publicly announced it only because we want to make sure that we pressure test our internal IT systems to make sure we got the patient workflow and all of those things going perfectly. But if you're a man or a woman that you've got breast cancer and your breast cancer, this is Breast Cancer Awareness Month, and your breast cancer's come back and you are interested in a functional precision medicine approach to treating your cancer, we're available to help.
That's incredible. And I know we're talking about breast cancer for this particular podcast, but do you work across all cancer types? Or are you focusing on specific ones at this trial phase?
We work on both liquid and solid tumors. We validated the platform across 43 different cancer types. And so we are, it's called pan cancer. We work across all cancer types. That's the way the beauty of the technology that we've developed is it allows us to enrich these cancer cells, and it is cancer agnostic. It doesn't matter if it's a blood cancer like leukemia or if it's a solid cancer like breast cancer.
So that dovetails perfectly. So is your background then more on the tech side or the science side, or how do you bring this all together?
Yeah. So we're actually where biology and technology converge. So a lot of people are like, are you a biotech company? And it's actually the opposite. We're a tech bio company. We've used biology and a proprietary biology method invented by our co-founder and cancer researcher, Dr. Diana Zom. She is a professor at Florida International University, a cancer researcher. She's the inventor of the technology. Dr. Berlow is a PhD in electrical engineering, bioinformatics, and machine learning. And we brought that biology and technology together to develop this solution that can help, we believe, so many people fighting cancer. And it is a combination of the biology and robotics and AI and technology all brought together, and we've been testing and validating this platform for almost a decade.
Oh, wow, really? That's really great to know. So, and I hear this a lot too in whether it's the tech bio or biotech space, we're in it for the long game, right? It's, some people when they're starting off and doing clinical trials, it's like, okay, we know it's going to take years for like the testing and the data to come to fruition. So that's good context right there.
Yeah. And I think that's one of the biggest gaps is I call it translational research. How do you move from the bench to offering this in a setting where patients could get access to it, right? How does it move from basic research to a solution? And that's really the gap that we've been able to bridge with our CLIA lab in Miami is to be able to take this technology that's been invented, tested, validated, and be able to offer it to patients that are in desperate need.
Yeah. Yeah. I almost want to ask, so where do you see this going next? But it sounds like you're at the forefront of this is what is next, what you're creating.
Yeah. Well, I kind of go back to, again, the name of the company, right? We named the company First Ascent because we will be the first to ascend in a number of these areas. Mm-hmm. Ideally, if I had a crystal ball and a magic wand, ideally, I would love to see this technology implemented upon primary diagnosis. So many, in 2025, a lot of people don't realize this. In 2025, with all of the technology and all of the tools and all of the drugs, 1 in 3 cancer patients still die. It'll be the number 1 killer of men and the number 2 killer of women under 50. And it is the number 1 killer of children by disease type. We lose 5 kids a day to cancer. And that's unacceptable. And so if ultimately we could move something like this to the forefront upon primary diagnosis, and we can do it with safety and efficacy, with data around the individual, that would make me the happiest person in the world.
I know that we're just kind of talking big picture on this new innovative space that you're creating. And, one of the questions that I have hanging over my head is this is fantastic. You're going to be eventually pressure testing to make sure that this could be available to more people, not just through a clinical trial process. But how much is this going to cost? And do you work with insurance companies?
Yeah, great question. Today, it is patient pay.
Okay.
Right now, insurance companies will reimburse for DNA RNA sequencing, which is part of our process. DNA RNA sequencing runs between $4,000 and $6,000. Our process includes that. but we also include the cell enrichment and testing hundreds of drugs. And our cost will be slightly above the DNA RNA sequencing alone. It's interesting because I had a choice to make, and I'm uncomfortable charging patients anything, but I had a choice. And the choice was I could release this technology and start helping cancer patients today with the goal to reduce the cost to almost nothing in the future if I can get there. Or I could withhold the technology until I could make it free to everybody. And so I chose to get it out there and start helping patients today. We surveyed 1,500 patients in America, average salary $87,000 a year, and we asked, what would you be willing to pay for something like this? And 87% of them came back and said they would pay well in excess of $15,000.
Wow.
And we're trying to bring this in at half of that, if not more. And then, ultimately, if we can start working with pharmaceutical companies, because that's the other half of what our platform has the ability to do, is we can actually accelerate drug delivery, drug discovery to pharmaceutical companies. Because again, think about it. If I can build a body of data that shows that trastuzumab is effective against bladder cancer, I can actually return that data to a pharma company, and they can take that data to the FDA and get, it's called an emergency IND that would allow them to potentially begin to offer that patient or that patient population that drug. So that's where, if I can bring in some of the pharma revenue, I can reduce the cost to an individual patient.
Yeah, absolutely. And I think, when you were saying that you're testing like hundreds of different types of drugs against the tumors, I remember when I was being treated, it was like $17,000 for one, infusion of Herceptin or something like ridiculous that I know I would definitely be broke had I had to pay out of pocket. And so,
well, and that's the beauty of the patients that we've had in our clinical study. We've got several examples where, patients being treated at $22,000 a month and 100% ineffective. And we get the biopsy, we begin guiding treatment, and the cost goes down to $100 or $200 a month. So not only do we have the opportunity to improve outcomes, but we also have the opportunity to significantly reduce costs.
Absolutely.
And in fact, we actually have an insurance company who is sponsoring a health economics study on 100 pancreatic cancer patients that study hopefully will be opening up soon, because again, to be able to show that a platform like this and a technology like this can dramatically improve outcomes, but more importantly, significantly reduce costs. One of our patients he was on Good Morning America, his name's Logan. Logan's an amazing case study because Logan had leukemia, went through a bone marrow transplant, quickly relapsed. We were able to get his leukemia into remission. And then also we identified what was stimulating his cancer. And more importantly, we eliminated a drug that would have had zero effect on him, and it would have destroyed his heart for the rest of his life. Logan's here today, healthy, happy, 8-year-old little boy, playing Little League and healthy, happy heart because, we worked with, Dr. Maggie Fader out of Nicholas Children's Hospital was the one that used our data to help guide his treatment. And like I said, he's here today because of that.
That's incredible. We need many more stories like that. I love hearing that.
We
sorry, go ahead.
Oh, no, I was going to say, it's interesting. We actually got a letter, 3 weeks ago or 4 weeks ago from a doctor. Again, same, patient had an orbital demoplastic small cell tumor. So basically in the eye. The patient was at home on hospice. We returned results. The doctor selected the drugs based on those results, started treating. The patient went back to school, back to playing football, back to a normal life. And I think those are those are illustrations of what the power of functional precision medicine can deliver. I mean, when you think about it, 42,000 men and women die from breast cancer every year. And to be able to have an impact on that is a great opportunity to help a lot of patients that desperately need help.
Absolutely. I get into these philosophical conversations of using the word like cure, right? Like, when are we going to find this cure for breast cancer or any cancer for that matter? But then it's like, well, does the cure already exist? And we haven't found that match yet, right? And so, yeah.
And that's really, Laura, that's really it is, everybody, I call it, everybody's looking for the silver bullet. And I hope they find it. In immuno-oncology or CAR T, or, it's in the organoid, or it's in proteomics, or whatever. Fundamentally, we're saying, I hope they find it, but I believe we have enough bullets. We're just not using them in the right way.
Yeah.
And that's really the basis behind what we do is we figure out what works for you. We give that back to the doctor, and you and your doctor have that conversation. And that's really the basis of what we do from our functional precision medicine perspective.
That's encouraging. I really appreciate this conversation, Jim. And I want to give you a moment if there was anything that we haven't discussed or chatted that you want our listeners to know, or that I haven't asked, because sometimes when we get into some of these deep science questions, I might not know exactly what to ask you. So giving you a moment of, is there anything that we haven't touched upon that you really want people to know?
Yeah, I think a little bit about my story is I'm not a PhD. I'm not a biologist. I had a son who was one of those 1 in 3 cancer patients. And he ultimately died from cancer. And I've spent my entire career in technology solving complex problems. And what I saw was doctors and nurses and hospitals, insurance companies and drug companies trained to do everything they could to save my son's life. But they didn't have tools and technology available to their fingertips that I had as a technology executive to make important decisions about cancer. And I knew it was a solvable problem. And I couldn't solve it in time to save my son. But that really was the fundamental basis of why I started this company. And then to be able to partner with, world-class cancer researcher and an AI expert before AI was even AI, right? And to be able to test and validate and publish. And it just feels like all of these things have converged at the perfect time. And I think that's the exciting thing for cancer patients. It's, I always tell cancer patients there are 3 questions you should always ask. Number 1, have any technology that you're going to select, has it been prospectively published in a peer-reviewed journal? Number 2, how many drugs can they test? And then number 3, how quickly can they return results? Because what we know is any delay in treatment of greater than 30 days, your mortality goes up by 10%. So it's important that you can turn it around quickly in a clinically actionable time frame, that the results have been published in a peer-reviewed journal like Nature Medicine or New England Journal of Medicine or Lancet, right? Not a pay-to-play. And that, again, the more opportunities to test more drugs based on proprietary technology will give you ultimately more options, more treatment options specific to the individual.
Yeah, absolutely. So I always love to end my podcast with what I call my lightning round of questions that I did not tell you in advance.
Okay.
And just really fun, get to know you as a person, as a human, etc. I just don't think too much, just answer what comes to mind. And this happened to me actually on another podcast that I was a guest on, so I'm stealing their ideas. But I did not have the option to pass. And sometimes when someone's like, oh my God, they just asked me this question, and like my mind went blank, I can at least say it was due to like chemo brain. But if you want to pass, you can always pass. All right. So in terms of animals, are you a cat or dog person?
Ooh, that's a really tough one because I love them both. I have actually 2 golden doodles sitting at my feet right now, but I love cats because cats have a little bit of spunk to them, right? They decide, I'm not going to let you pet me today. So if I'd had to choose, I would probably say I'm more of a cat guy.
Good to know. In terms of vacationing, beach or mountains?
Definitely mountains.
So where do you love to go hiking or camping or outdoors?
Yeah, it's all of the, I love the beach. I scuba dive. I hate sand. So I love mountains. I love anything outdoors, but yeah, mountains.
I know you're super busy running your company, but in your free time, are you watching any Netflix series or any movies you've been watching lately?
Yeah, I am. I'm actually watching, it's called The House of David. It's about David from the Bible, and that's a pretty interesting one. But I think that's about it. It's mostly just trying to stay focused on task at hand.
Absolutely. I run a book club. And I just find myself listening to Audible all the time, trying to multitask, even though I really need to put the screen down, open up like an actual book and like read for pleasure. So I can appreciate that.
Yeah, it's mostly, I mean, I know I sound a little bit weird, but, I wish I could read, books, but my mind is going too many different directions all at the same time. So honestly, the reading that I do is all about AI and where things are going from AI perspective, where things are going from technology perspective. So it's always kind of, I don't want to say technical stuff, but it's stuff that draws my interest so I can focus on it versus, Wild Wild West series where I'm reading 20 pages and I'm like, oh, wait, what did it say?
Exactly. So definitely not into escapism. You're like in it for the good of your company. So I can appreciate that. Well, Jim, thank you so much for taking the time to speak with us to enlighten our listeners about First Ascent, all the incredible work that you have painstakingly done over the last decade, and really have it's all coming to this beautiful crux today and helping more and more individuals. So thank you for sharing this great research with us.
Well, thank you for the opportunity. Like I said, we've all been touched by cancer. I mean, I wish my story was unique. It's not. These are our brothers and our sisters and our mothers and our fathers and our children. And to be able to offer them something, again, this will be my legacy on humanity. And, I'm often asked, what does success look like? And, it's actually pretty simple. It's, one life that's here because of something I did. Now, if I can do that 10,000 times over, that's even better. But that's what it looks like to me. So I thank you for the opportunity. I think it's important for people to know about what is functional precision medicine and try to demystify it. It's not that complicated.
Mm-hmm. Yeah, great. Well, thank you. Thank you again. And we'll definitely keep following you, and can't wait to hear how this evolves over the next couple of years.
Well, thank you. I appreciate it.
And thank you, everyone, for listening to our show. I would like to acknowledge that all of the information on our podcast is from personal experiences and is not a substitute for professional medical advice. You should always contact your medical care team. If you are looking for specific topics or would like to be a guest on our show, please feel free to reach out. My email is laura@survivingbreastcancer.org. Our show is made possible by our nonprofit, survivingbreastcancer.org, and by our incredible donors like yourself. You can hop on over to survivingbreastcancer.org to sign up for our mailing list, make a donation, and explore the 400 plus programs we offer each year at survivingbreastcancer.org/events. Until next time, keep on thriving.